Okay, so in this video, I'm going to do some examples of integrals with products of sines and cosines. So I'm specifically going to do these two examples just so you can see how everything works. So for this first one, okay, so these types of problems where you've got sine of 3x, cosine of 2x, so like two different numbers here, the only way you can do this is by using our products of sine and cosine formulas. So you can pause the video if you want to write these down. These are very helpful for these types of problems. So this, this little property here, this is what I want to use. And so for my m, I'll use 3, and for my n, I'll use 2. So let's see. This will become, I'll bring the 1/2 out. And so then this is going to be sine of 3 minus 2x plus sine of 3 plus 2x. So now I need to integrate sine x plus sine 5x. And okay, so now this will be 1/2, and let's see, so this will be negative cosine x minus 1/5 cosine 5x plus c. So in the end, I've got negative 1/2 cosine x minus 1/10 cosine 5x plus c. So the only way you can do these is by knowing those identities. That's it. And once you know them, it's much easier. But this problem would honestly feel impossible if you didn't know those identities. Okay, so for this next one, this is a little trickier because now I've got cosine squared 2x, sine of x. Okay, so let's maybe appreciate like what's the first thing that we've got to do here. So I'm going to go to my list of helpful identities. And so I've got that 2x in the problem, which like kind of makes me want to use, I don't know, one of these two identities. This is like my list of just quick hit identities that are very helpful in a calculus class. You can pause and write them down if you want. Okay, so here's the way that I think about this. I don't really want this to be squared. I really just want this to be sine 2x. So this is equivalent, right, to sine squared 2x. So I've just rewritten I think it's sine, cosine. So I've rewritten my cosine function. And now what I'm going to do is I want to put everything in terms of, how about cosine? So I want to use this identity here, and I want to isolate this cosine 2x for a second. So how would I do that? If I wanted to solve for cosine 2x, that would be 2 cosine squared x equals 1 plus cosine 2x. So check this out. Cosine 2x then equals 2 cosine squared x minus 1. Okay, so let's replace this cosine 2x then with that identity. So 2 cosine squared x minus 1 squared sine x dx. Okay, so this actually resolves some problems for us because now we've taken this looks like I have 2x and x, but actually now, keep doing that. Okay, I have now rewritten this without the 2x, so now I've got cosine x and sine x, which probably means that I can use a substitution here. So let's go ahead and FOIL this out. So this is 4 cosine squared x minus 4 cosine squared x plus 1, and then sine x dx. Okay, so this I can work with, right? So now, and this should have been 4 cosine to the 4th, my bad. Okay, so now I can set my u equal to cosine x, and my du will be negative sine x dx. So I have negative du equals sine x dx. So let's clear some space, and let's set up a new integral. So I'm going to put that negative for that du. I'm going to put it right here. And then this will be 4 u to the 4th minus 4u squared plus 1 du. Much easier to integrate, right? So this will end up becoming 4 over 5 u to the 5th minus 4 over 3 u cubed plus u. And so now we can distribute and fill in the original function. So this is negative 4 over 5 cosine to the 5th x plus 4/3 cosine cubed x minus cosine x plus c, of course. All right, so that one was a little bit of creativity, right? Okay, and so that is the end of this video. Thanks for watching, guys. I will catch you in the next one.